Good morning, friends. Myself, Dr. D.KISHORE. So, before discussing about my research topic, I would like to give you my brief introduction about myself. So, I basically from native place of Pipulpalam. So, I have completed my B.Tech from Bapa Engineering College in the stream of electronic instrumentation. I have completed my M.Tech from Process Control Institute from NIT Tiruchirappalli. After that, I worked as a faculty in V.R. Siddhartha Engineering College for the 4 years. After that, I have completed my Ph.D. from National of Technology Warangal. So today I would like to give some briefing about my research work. So first of all, let us go into the details of my research work. So let us see what is the topic of my research work: identification, control of cross using relay feedback and subspace approach. So this is the title of my research work. I just want to give a brief introduction about my research work. So this is the output of my introduction, literature review. So first of all, what is mental action and what is the topic of what is the importance of my research work? Literature review, motivation objects of the study, research methodology. What is the research methodology I have kind of? Relay feedback and subspace. These are the methods I have used in my research work. Case studies where relay feedback and subspace and provide relay feedback subspace methods, recent discussions and conclusions, scope and picture study, publication and references. So first of all, the title of topic is identification of identification control of process relay feedback approach. So first of all, what is meant by identification? So identification is defined as an exercise of building a relationship between the input and output system from the measured data. So for any process, it is suppose we want to identify any system, we require the input output data. So input output data is it is done by carrying out some experiment. So there are two types of identifications are available: open loop identification, closed loop identification. So in open loop identification, excitation is given at the input of the process and output. Excitation given at the input of the process and output is recorded. So in open loop identification, the problem is that is some noise is problem in the open loop identification. So in order to overcome that problem, again we are going for the closed loop identification. In closed loop identification, some form of excitation is introduced in the set point and the output response of actual process obtained. So when compared to open loop identification, closed loop identification is somewhat more accurate because closed loop identification will derive from the noise, or there is accuracy is more in the closed loop identification. So there are methods. These are the various methods available for the closed loop identification: Jaden approach, relay feedback approach, relay feedback to symmetric, relay feedback asymmetric, subspace method, relay feedback to subspace method, relay feedback to topic, relay feedback symmetric subspace approach. So this is literature. Literature is nothing but what are the research work has been done in the previous. So that is we have arranged in the form of some tabular form. So these are the different kinds of literature I have carried, because literature is nothing but signifies what is the amount of work we have done in the previous. So that is called the literature. So suppose we want to do something, means we have to know what are the existing has been done in the previous or past. So that is called the literature. So literature is arranged in the form of this tabular form. So from the literature we can understand what they have lacked or what they have left out something to do. So that is called the research. Research is already existing. We need to find out what are the drawbacks or what are the things which are left out for doing the next time. So that is called the literature, or that is the gaps identified from the literature. This is called the gaps identified from the literature. What is the left out from that is called the gaps. So most of the methods developed for the identification process are based on the extensive mathematical modeling and involve a lot of computations. So mathematical modeling is represent the process in terms of the equations and in terms of equation and the laws. So these, suppose if any process can be represented in terms of equations and laws, the complexity of the process is very high. So in order to reduce that problem, we can go for the trial and error methods, and complexity is more when the order of the system increases, and that requires more approximations. So motivation objects of the study. So motivation and object is nothing but whatever the literature we have collected. From that we got the gaps. From that we have to understand that we have to find out the objectives. What needs to be done. So already something has done in the previous. What needs to be done in that is called the objectives.
So these are the objectives I have framed based upon the past or based upon the literature I have gathered. So the following objects have been framed based on the gaps in from the literature. To identify the process to modify relay methods for system and memo process. To identify nonlinear systems with modify relay feedback approach. To adapt the simplest method based on subspace and relay approach. Combination of subspace with relay approach to identify the control of 2x2 memo process. To develop the improved technique for the identification control of a 3x3 memo process using subspace and relay approach. So this is the research method. Research method is nothing but what are the methods we have adapted or what are the things we need to adapt in order to doing the research. So in this relay feedback approach, asymmetric relay feedback method, relay feedback is subspace approach. So this is the controller diagram, or this is the identification of a process. So this is a process. A process may be a chemical process or electrical process or mechanical process. So the input is given in the form of a step impulse of a input process and the output is noted. So from this we can identify the process parameters. The process parameters is nothing but the process gain, time constant, and damping ratio and dead time. And this is the from this we can get the controller parameters. Controller Kc, tau y and tau d. Proportional gain, time, integral time, derivative time. So this is the schematic of relay feedback control system. It is nothing but the control system. So the here in terms of the relay we are replacing in place of a control we are replacing with the relay and we are getting the some input output. U is the input and y is the output. So U is the height of the relay is the input, y is the sustained oscillations are the output. So these are the relations we got from the this after simulation of this process we got these relations Ku and omega. Ku is the ultimate gain, omega is the ultimate frequency, and identification. Now let us come to, because previously we have we took the literature review and from that we have find the objectives and let us know how to allow these objectives, or let us see how to establish or how to complete these objectives. So the first objective is to estimate the parameters of the process using the modified asymmetric relay feedback method to design a simple PID control for the estimated process. So modified asymmetric relay feedback. In this work, a relay feedback test was conducted with a sinusoidal excitation and the asymmetric relay for the excitation of the process. In this work, a sinusoidal input with standard amplitude and asymmetric relay with the heights plus h minus 2 which were used in order to obtain the sustained oscillations. So this is a schematic diagram of our relay feedback system. This is the diagram I have followed in my work. So this is nothing but this diagram has been done from the software MATLAB software, and this is sine wave, and this is sine wave signal. This is a relay, and this is the transfer function. Transfer function will represent the process, and this is the transportation delay, and this is the from this we will get the input output data. Input output data in the form of the graphs. So just giving the some overview of this one. So this is the input of the sustained oscillations generated from the relay feedback system, and these are the parameters that we need to determine after getting the input output data. So these parameters are the process gain, time delay and time constant, and from this we can now let us take the processes which are in the literature review. Literature review is already those processes already exist in the literature. From this we can take the each and every example and let us apply our own method. So this is the GFS is a transfer function. Transfer function this is a second order system. That is order of the system is now let us see what is when the second order system is. Order is 2. So second order system is nothing but the inverted pendulum. Inverted pendulum is one of the best example for the second order system. This will represent the second order system. So now let us identify these process parameters Ku and omega u, and these are sustained oscillations we got from this, and this is the control response we got. So control response means it will try to see that the process runs at a certain time. And the case study to similarly we took the first order system with the delay g of x equal to e power minus 2s by 10s plus 1, and similarly the same analysis has been carried out and the sustained oscillation is generated and control response is obtained. Similarly for the unstable process, the same analysis has been carried out and the sustained loss is generated and the control response is generated. Similarly, for the case study 4 also, second order plus time delay system, the sustained loss is generated and control response is obtained. So from this we got these are the parameters. So based upon the simulations, based upon the calculations, we got these are the parameters required, and this is the control parameters obtained. And that is, we have done some research and we need to compare with others methods. So we need to my method is called the present method. I am comparing my method with the Chidambaram method, and when compared to that method, we are getting the ISC value is very less. That means error we are able to, error is nothing but it tries to reach the closed value. The error is very less when compared to the other methods that is done by the researchers. So that is my error is when compared to that methods we got the. So this is the significance of any research. Now, suppose if you do any research, it should be compared to the others in that field, and from that we need to identify, we need to find out whether our method is giving best result or not. So that is only if you compare with other methods only we came to know that our research is giving good result when compared with the other results. So from this we are getting the less error is 3.94. So again compared with Chidambaram method, in second case also we got the less error. When compared to Chidambaram method, third case also we got the less error. So this is the we got the our own results after finding the research on our own topic. So this is in this work modified symmetric feedback method along with the science of used to identify the various parameters of the stable associated unstable system unlike other methods. The method was compared to the method proposed by Chidambaram method. The improved method was observed to give the better identification in terms of ISC when compared with the methods. PID controls were designed using the delay feedback approach with the ZN settings.